Hey everyone, got an Ask the Trainer question today that actually didn't come from someone that wrote in. It came from a virtual baseline training that I just did this last week. And it's about my 9-volt battery trick. I didn't actually invent it, but I want to share this with you. We're going to take a simple 9-volt battery and we're going to make it work for us out in the field. It's a great little troubleshooting tool that I've used. Let's go over and take a look at it. Irrigation systems have been designed to run on 24 volts, sometimes a little closer to 30 volts. The solenoids are an electromagnet that will be activated when there's 24 volts that runs through that. Well, I've got a 9-volt battery. Generally that's not quite enough. Add another 9-volt battery, I've got 18 volts. And then when I add a third battery, I get 27 volts, and that will open just about every solenoid that's out there. Now I have to combine those voltages, so here's my trick that I found works really well. We've got these snap ends on the battery. Well, they can just go end to end, so I'm going to snap these two together. Now I have 18 volts, and then I'm going to snap this next one together, go positive to negative, and I'll snap in. And now between these two terminals I have 27 volts. So let's make that work for us. So I'm going to take the two leads of my solenoid here, and it doesn't matter whether it's an AC solenoid or a DC solenoid, this will work. And I'm just going to touch them onto these two, and let's listen for the click of the solenoid. So you get a bit of a click, and maybe you can see this spark there. Yeah, there's the spark. So we're getting a click from the solenoid. So that solenoid's activating with 27 volts. So let's take a look at how we're going to make this work for you out in the field. So we're going to get rid of my one solenoid that I have. And let's take a look at a 2-wire system. So on a 2-wire system, I've got my connection onto the 2-wire side, and then the output side is the solenoid side. And this is we're only talking about testing this side. This is not a test we'd use for the 2-wire path. This is a test only for solenoid side. So I've got my solenoid, and then I've got my splices. Yeah, these are not the correct splices. These are just a great demo splice that are easy for me to reuse. So first thing I'm going to do is disconnect that splice from the solenoid, and I'm going to isolate my solenoid from my 2-wire path. So all I have is my solenoid. Well, now I'm right back to where I was before. So I'm going to take these two leads. Yep, solenoid's working. Now there's another tool that makes this step even easier, and let me show you what that looks like. Go get some cheap test leads from an electronic supply store. These are probably old enough that I've got them from Radio Shack when they used to exist. I'm just going to clip onto those. So now I have fewer connections to juggle, and I can just touch that on the battery terminal, get a little spark, and you can hear the solenoid going. Or what we could do is, if I need to actuate and run the zone for a period of time, if I actually need to use it to water and I can't bleed my valve for some reason, I can actually clip it on there and leave it energized. And it's going to drain the batteries rather quick because we're energizing this, but it will work. So that's 2-wire. Let's take a look at conventional wire and see what that looks like. So in a conventional wire system, there is no bicoder out in the field. The bicoder is actually back in the controller, and it's connected to a power bicoder, which it looks something like this. The power bicoder technology is hidden behind this board, and then we're just connecting onto these screw terminals with wire only. So essentially everything after this terminal is solenoid side, and this is all 2-wire side from this side back on. So back at the zone, it's almost the same thing. We're going to break that splice and test just the solenoid only. And now we can do the same thing. We can test this onto those 2 screw terminals. And we can hear that solenoid click. Now, on a conventional wire system, we also have the option of coming back to the board itself and disconnect. If you disconnect the common wire from the terminal here, I can put a 9-volt battery lead on this terminal and then connect the other one onto the common wire that's coming out, and I can send 24 volts from the controller out this way. That way I'm testing the entire wire path, and the return all the way back, so I can check it all in the loop. So I can actually check this wire at the same time. Now keep in mind that these checks, we're not getting any voltage, any resistance reading. It's just a straight, does it work, does it not? Where I might use this 9-volt battery trick or hack, if you will, is I might use it as another tool in your toolbox, something else that you can hang on to, that you can use to test, you can verify. Or if you have technicians that haven't mastered the use of a volt ohm meter, also known as a multimeter or a milliamp clamp. If they don't know how to use either of these, this is another down and dirty tool that you can use to verify solenoid side only out in the field. Have a question for me? Click the link in the description and go to hydropoint.com/askthetrainer to submit your question.